This is a special talk for me because I have spoken about the science of remote viewing in international venues and in university settings around this country and the world. And in each of those presentations, I focused on a particular aspect of the remote viewing phenomenon. Today is interesting for me in particular because I'm tying together things that I have not been able to tie together before. In specific, I think I understand why the remote viewing phenomenon works, and it is directly connected to quantum mechanics, and I'm going to explain my theory about why that actually does happen. And so when we understand the process and its reality, we really come to an understanding not just of the nature of physical reality being different, but the lessons we have learned from remote viewing can teach us a great deal about the history of our own civilization. So I am Courtney Brown. I'm the director of the Farsight Institute. I consider that the leading science shop anywhere where we study the phenomenon of remote viewing as it is performed using procedures that were developed by the United States military and used for espionage purposes, or methodologies that are derivative of those procedures. I work with people such as Glenn Wheaton, who is director of the Hawaii Remote Viewers Guild. He is out of Special Forces Intelligence, and Lynn Buchanan, who is the leading instructor of controlled remote viewing, and he worked out of Defense Intelligence Agency. And they have trained a large number of viewers, and those viewers work in our experiments that we conduct at the Farsight Institute over a great many years. So let's begin with some basic facts that I'm going to be talking about. Remote viewing can transfer information across both time and space in apparent violation of the accepted theories of Newtonian and relativistic physics. Now, information is physical. That's not in dispute. We normally think of information as just stuff we know, but that's not what information is. It's called information theory, and it's been well accepted in physics and other realms. It was originally developed independently by Norbert Wiener and Claude Shannon, but basically information is equivalent to mass and energy. And there's been a thought experiment for a long while in which one was able to convert information into energy, and it has recently been actually performed in a laboratory. So they actually have been able to convert information into energy. Now this scares physicists a lot, because if you're transferring information across time and space, then what you're actually doing is the equivalent of transferring energy or mass across time and space. And that's really interesting because it really is in violation of what we know about physics in our current paradigms. Now, let's make a conclusion from that. First, transferring information across time and space must be, if we're to generalize, it must be a general feature of reality. We cannot say it's an exception to reality. There must be something general about it that we're not understanding that we can generalize and say it's a statement of reality that incorporates that. Also, the past, present, and future must exist simultaneously. For example, a remote viewer is working in real time, remote viewing something under totally blind, squeaky clean conditions that's in the past. Well, that has to exist when the remote viewer is doing it, otherwise the remote viewer could not do it. So whatever theory we do come up with, we must be able to say that that past, present, and future occur simultaneously. Now, there must be some mechanism that prohibits or inhibits us from perceiving the past or future in our normal awareness. So something is going on in our minds where we don't see what was happening yesterday, and we don't see what's happening tomorrow. We see only the now. Okay? So we have to be able to figure out what that could be. Now, let's start with some basic non-conflicting assumptions. The first is that only energy exists. Now, c, the speed of light, is a constant. C squared is a constant, so it's basically just a scaling factor. So energy equals mass. So energy and mass are equivalent. Now, all energy can be defined in terms of frequencies. All that exists in the universe must result from frequencies that coexist in states of superposition. Now, I'm going to explain that a little bit later, but those frequencies are all that's out there, anywhere. And those frequencies have to do something with themselves in order to produce us. And it's that state of superposition that that thing happens. And we have to say that there can be no special consideration of the macro world as isolated from or separate from the quantum world. We cannot live in a world in which what goes on in Vegas stays in Vegas. We can't live in a world in which there's an imaginary line of decoherence, and what goes on in the quantum world stays there, and what goes on in the macro world and the classical world stays here. We have to generalize so that it incorporates both. Those are the assumptions that we want to be able to start with. If we're going to get someplace, we have to get those things answered. So let's start with the picture on the left. Picture on the left has waves that are in sync. That means the peaks of one wave is matching the peak of another wave. Now, the trough of each wave are also matching. When you add them together, they sum up together and produce a bigger wave. Now, on the right-hand side, you see that the waves conflict. So what you have is the peak of one wave matches the trough of another wave. And what happens is they're conflicting and canceling each other out. So on the left-hand side, we have constructive interference, where they're amplifying each other. They're summing together. On the right-hand side, we have destructive interference, where the things are canceling each other out. Now, those are the only two processes which we are going to allow in the entire universe for this theory. Nothing else. These are some sine waves. Now, I just put these sine waves together. They're actually banded around a common wave number, similar frequencies. And what you see here is what happens when you add those things together. You get that. You get a wave packet. Now, normally you can think of these things, these constructive and destructive interference patterns, in the following way. Go over to a piano and bang on middle C, and then bang on B right next to it. You'll hear the beat frequency, wah, 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 wah. Now, bang on C again, and then pick the highest B you can get on the keyboard. You won't hear that beat frequency. There actually is constructive and destructive interference, but it's nothing to write home about. It is nothing to write home about. The frequencies really to really interact in constructive interference, they really should be fairly close. That's why physicists like to take a common wave number and then go a little bit out to each side to group those things into a superposition. Now, that is a wave packet. This talk and my theory is very closely aligned with Hugh Everett's ideas that were basically published in his dissertation in 1957 that he did in Princeton under John Wheeler. Now, the basic idea is that all that exists in relative states. So you have stuff that goes on in a subatomic particle, and that produces a superposition, a bunch of waves adding together, and that wave is like a snake. You see, a snake eats a rat, and when that rat gets eaten by the snake, it produces a bulge in the snake. And that bulge in the snake is, well, the snake is like the fabric of reality, and that bulge is like a bulge in the fabric of reality, and that is the superposition. So, basically what we're talking about is that when you have that quantum particle creating that superposition, physicists have long stated those superpositions can happen anywhere in the electromagnetic spectrum. But Hugh Everett came along and said, well, you actually get relative states. You don't really have an external observer that's independent from an isolated quantum system. That observer, when that observer watches that, and as John Wheeler said, nothing really happens in the quantum world until it's registered, observed in some fashion. And when you actually observe that, that person becomes part of the overall stuff. So you don't have anything that's really isolated. You have a wave function for the superposition of the quantum particle, but you also have a wave function for the observer and the particle. That means you also have a wave function for the building that the observer's in with the particle. And then you have a wave function for the Earth, and you have a wave function for the solar system, and yes, there is a universal wave function. So what you have is relative states. The terminology, the real problem, if there is any real problem with Hugh Everett's stuff, is that the terminology was not sexy. So the idea of relative states didn't really catch on in the terminology, but the mathematics was really solid. And if you look in physics departments these days, that's where the real rage is. The real rage is not in, wow, the Copenhagen interpretation is great, the collapse of the wave function. What we really have is the excitement in the discovery that Hugh Everett stuff is really now. And so what you have with the understanding of the wave function is better described, in my view, not in terms of the words relative state, although there's nothing wrong with those words, but I like the words superposition ensembles. Superposition ensembles are basically this. You have a subatomic particle. Aggregate out, and you have something larger, an atom, a molecule. That's an ensemble of various superpositions for each one of those little things. You and I are superposition ensembles. It's the same idea of relative states that Hugh Everett came up with, but we can understand superposition collections or superposition ensembles. And so the planet is a large superposition ensemble. Now, physicists have a very interesting idea. Here's the electromagnetic spectrum. Basically, they don't talk about superposition ensembles. What they basically talk about is superpositions, but it's implied in the language that's common today that superposition ensembles, using my terminology, exist within the electromagnetic spectrum such that the frequencies that interact with us are in the visible light spectrum. For example, light enters the retina. It enters as a wave. It has certain frequencies associated with it. It hits the retina. The retina is a superposition ensemble itself. The frequencies mix with the light, with the retina, to produce a new thing, a new superposition ensemble. And that gets translated by the brain to a spot of light. So the basic implied understanding with physicists are that the superposition ensembles, if they were using those words, really only exist in realms within the electromagnetic spectrum that intersect with the visible spectrum. That is why long radio waves, gamma rays, X-rays, UV rays, they don't affect us. They go through us. So the gamma rays and X-rays, those are just light, high frequency, high energy light. But they basically don't really affect us. When they come in really strong strengths, they have nonlinearities that can cause disruptions in our DNA, but generally speaking, they don't interact with us. So the point is, they're too far away. But there is theoretically nothing prohibiting the idea that you could not have aggregations of superpositions elsewhere in the electromagnetic spectrum. Other worlds, elsewhere, higher up, where the frequencies are closer together, higher density. So you could have aggregations or octaves up within the electromagnetic spectrum where you have worlds, people, things like that, and we would never see them. This is Schrodinger's equation. The Schrodinger's equation on top is a partial differential equation, and it's very interesting because it has a solution that's right down below. Oh my gosh, I forgot something. This is really, really important. Oh, I have it. Thank goodness. I was wondering if I was going to go hungry today. I remember now I have a quarter. Whew, here it is. This quarter is going to save me. Well, yeah. I have it here. Well, you see, this is a different quarter. This is not the first quarter. So I have this is another quarter. And you can say, Courtney, what are you talking about? I saw the quarter. You just moved it from one hand. What are you trying to pull on us? You moved it from one hand to the other. I saw it. I saw it. And I said, no, you don't understand. The quarter that was in that hand, it had an equation. It was a different quarter. You see, this is a solution form. Now, this is a non-relativistic form of the Schrodinger's equation, but nonetheless, look at the solution form. It has a t associated with it, time, and it has a space associated with it. The quarter in this one has a different equation. It is a different quarter. It is not the same quarter. So what we have is a situation in which when we move in time and space, we're actually changing the equation. And that's really crucial because this is really what I want to say. Garrett has sometimes said, you're a bit cocky, Courtney. But I want to say this is beyond Garrett's previous characterizations of me. I've actually modified Schrodinger's equation. Watch this. Call this the Brown modification. So notice that everything is here. I didn't fiddle with the time, I just fiddled with the x, okay? So notice here that where you see that x, that s up there, that used to be an x, that used to be the placement. So you could actually find, the location where this stuff was going on. And s is the distance of a known object A from another known object B, where B is located in original origin location, previously known as x sub 0 in Minkowski space. And I say that that s, which we're now using to measure distance, is actually 1 over u divided by, 1 over u minus 1. What is u then? So we said, okay, Courtney, you switched x to an s, and now you have a u buried in it. U is the proportion of total energy contained in two objects that is in a state of mutual constructive interference within the n total dimensions. I say n total dimensions because if you're a string theorist, you're talking about more dimensions, but let's just talk about whatever number of dimensions you got. So it's the proportion of total energy contained in two objects that is in a state of mutual constructive interference. That means you have two objects that are apart, okay? They each have a wave function. The tails of those wave functions spread throughout infinity. So they overlap to some extent. The more they overlap, the more they're in a state of constructive interference. The farther apart they are, the more they are in a state of destructive interference. So essentially what this is look at that 1 over u. Let's say they're very close. That means there's a lot of overlap. There's a lot of constructive interference. You can get close to 1. 1 divided by 1 is basically around 1. Minus 1, basically 0. What's the distance? 0. It's close. What happens if you're far away? Well, u is a really small number. Okay? That means there's almost no constructive interference. The proportion is really small. So you're dividing by a really small number. And that will produce a really big number. That means S will be really huge. So let's look at a distant quasar. Wow, that quasar is so far apart, you're only getting one photon at a time. That means the overlap between you as a superposition ensemble and the superposition ensemble of the quasar has very little overlap. That doesn't mean that there's a real physical dimension. That's what I'm getting to. There are no real physical dimensions. The quasar is right here with you, but you look at it as distant because you see only a very little bit of overlap. So you basically have constructive interference at such a small level, it looks distant. Stop thinking in terms of real physical dimensions and start thinking in terms of artistry. If you're to project something out far, you make it small. That means there's a little bit of overlap in doing that. Okay. Now, so the basic idea with this formulation can be illustrated this way. Here we have two wave functions. The one on the right is a big one, and the one in the middle, set at x equals 0, is a middle one. These things have little artifacts to the side, to the left, so don't worry about those. Now look what happens when I start merging them. See how they start getting more constructive interference as they get closer? You see how it gets... Now normally people would say, of course, you move them closer, they're going to be constructive interference. No, 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 you have it backwards. The constructive interference is what's going on. The illusion then is that they're closer or farther apart. With remote viewing, you're transferring information across infinite distances because there are no distances. There's only constructive and destructive interference processes, nothing else. This type of stuff is actually very mainstream. I've actually gotten into a lot of arguments here in the society with people who say, look, this multiple worlds stuff that you've been doing, Courtney, this alternate reality stuff, this is really far out. It's not far out. Mainstream physics is actually passing us. This is a big documentary that was done by, actually that's Hugh Everett's son, who's a pop star, believe it or not. And it was done by BBC and shown here on NOVA, telling how the rage in physics among young people, young professors, is not the Copenhagen interpretation, but the rediscovery of Hugh Everett's stuff, the many worlds, the other worlds stuff. And here's Brian Greene. You can't get any more mainstream than Brian Greene. He's just published a book, The Hidden Reality, on these other realms. So we as a society have to get used to the idea that it is okay to talk about that. Talking about stuff that we do at the Farsight Institute, based on this science that I've been developing, we've done a whole bunch of projects. The Multiple Universes project was actually just published, the data and the experiment and everything was just published in the couple months ago recent edition of the JSE, minus the multiple universes interpretation, the a priori theory behind it. Basically the reviewers and the editors and everything had trouble with the multiple universe concept, but they liked the experiment and all of the data and everything else. So everything got in there except the theory. So the basic idea is we have to get over this. The theory can be talked about. They're talking about it in mainstream theory, and we should not be embarrassed about publishing stuff that points to the idea of multiple realities. There was also a project that identified an anomaly on Mars that we consider a technological base on Mars, a really high resolution photograph from NASA, JPL, Malin Space Science Systems. We did remote viewing with people who are military-grade remote viewers with training of a decade or more. These people get non-trivial results. You're not talking noisy data sets. And we actually duplicated everything that was in the picture, but also we found out the other stuff. And that was another presentation I gave here, and it's also another project we did. We also explored a theory from the late Thomas van Flandern, where he talked about a huge amount of data that he discovered that was dealing with a planet that exploded between the orbit of Mars and Jupiter. Often scoffed at by planetary scientists, but the reality is the physical data are enormous. We did a remote viewing study on that, totally confirming Thomas van Flandern's ideas. He was the head of the Celestial Mechanics Department in the Naval Observatory, very mainstream. And we also did a project on planetary change, climate change between 2008 and 2013. All of these are summarized in a DVD that we've recently published. Basically, there's so much stuff on our website, farsight.org, that people are a bit overwhelmed when they get to it. It's huge stuff. We're a nonprofit. We give everything out. So we finally said, oh, let's put out a DVD that sort of summarizes a great amount of this stuff. So let's draw some conclusions. Everything has a wave function, including the universe. All wave functions extend throughout all of time and space. All wave functions and thus all superpositions overlap with other superpositions to some extent, including the wave function of the remote viewer. Thus, remote viewing is possible because the wave function of the remote viewer overlaps with all other things. Now, The human brain, that means, is actually a very narrow band hologram generator. That's the trick of the brain. It is able to select out only the frequencies it wants you to see. If you're out there in the wilderness and you say, hey, there's a lion there, you have to see that lion of today. You don't need to see the gazelle of yesterday, and you don't need to see the elephant of tomorrow. You need to see the lion of today if you are going to survive. The brain has evolved to be a very narrow band hologram generator. It screens out everything else. Remote viewers are simply highly trained to expand the band, to be able to see some of the other frequencies that are within their own wave function. That's why remote viewing works.